All right, 17A, number 1. Find the expected value for the sum of 100 draws at random with replacement from each of the following boxes. So, 0, 1, 1, 6. So first we need to find the total of the box, the sum of the box. So in this case, the sum of the box is going to be 8. What does the sum of the box mean? Okay, it's all of them added together. So how else do we interpret this? It's the expected value when you draw 4 times with replacement. Okay? So if I play this game 4 times, I expect to get 8 points. Now, with only 4 draws, the chance of getting 8 is not terrible, but it's probably not going to happen. You'll probably get something else. Okay? And we also want to find the average of the box. How do we do that? We divide the sum of the box by the total number of tickets in the box. So 8 divided by 4 is 2. What does 2 tell us? On average, each draw is worth $2 or 2 points or whatever this game is. Okay? Now, can you get 2 on a single draw? No, there's no 2 in the box. But the more you play, the closer you're going to be to 2 points per draw. So the question asks, how do we find the sum of 100 draws? We simply take this and multiply it by 100. And I get 200. What does 200 tell us? If you play 100 times, your expected value is 200. Now, most of you won't get that, but that will be the average of everybody's 100 draws. Okay, and the more times you play, the closer and closer, well, the more times the class plays, the closer the average of the class should be to 200. Okay. So we have a different box, B. So -2, -1, 0, 2. What is the sum of the box? -1. What does that mean? If you play this game 4 times, you're expected to lose $1. Better or worse than the last game? Worse, for sure. No casino would have a game like this, right? The worst you can do is break even. There are no negatives. Okay? So now we take the average of the box, and I take that -1, and I divide it by 4, and I get -0.25. What does that mean? On average, every play is worth a loss of a quarter. Is this better or worse than roulette? Worse. Roulette, you only lose 5.2 cents per play. So you definitely don't want to play this game. And if I draw 100 times, multiply that by 100, and I get -$25. So if you play 100 times, you're expected to lose $25. So don't play. Okay. Next one, -2, -1, 3. The sum of the box is 0. So the average of the box is 0. What's going on here? Yeah. If you play 3 times, you're expected to win $0. You are also expected to win $0 per play. So if I play 100 times, then I'm expected to win $0. Is this game worth playing? Yes, if you have a very large number of $1 bills in your pocket. If the average of the box is 0, there is a way to guarantee to win money. And I showed it to you at one point. So you bet $1. So you bet $1, you win $2, so I'm +1. Okay? You bet $1 and you win, so you get $2. Now I'm plus a total, so 1 plus 1 is 2. Okay? But I bet $1 and I lose, so now I'm at -1. What do I need to do? Now I need to bet $2. -2, and I lose again. So I'm at -2, which gives me a total of -3. So now I have to bet $4. -4, I lose. Boy, I have bad luck. So now I'm -4, which is a total of -7. Now I bet $8. So I'm doubling my bet every time I lose. So I bet $8 -8, and I win. How much do I win? I bet 8, so I win 16. Plus 16, which is +8, for a total of +1, and I add that back to my +2, and now I'm +3. Now what do I do? Go back to betting $1. If you win, bet $1. If you win, bet $1. If you lose, bet 2. If you win, bet $1. If you lose, bet 2. If you lose, bet 4. If you lose, bet 8. If you lose, bet 16. There's only one problem with this. If you don't have enough money in your pocket and you lose a whole bunch of times in a row, so you lose, now you bet 2, so you bet $3 total, and you lose, now you bet 4, so 4 plus 2 plus 1, 4 plus 3 is 7. You lose, you bet 8. 8 plus 7 is 15. So if you put together 8 losses, you're going to need $1,000+ in order to accomplish this. And in the end, you're only winning $1 at a time. $1 for every win. So Siri's telling you not to do that. What was she going to say? I wanted to know what she had to say. I wonder if she was listening to what I said. No. Okay, so in the end, don't do it. Is it likely that, for instance, tails is going to come up 6 or 7 times in a row? Not really, but it could happen. And if it does happen, then you're out a lot of money, right? You've bet. So if you play for an hour, maybe you win $50, right? But if 8 tails comes up in a row, then you've lost $1,000. So kind of frightening. But really, this is the only game at the casino worth playing. Okay. So the next one, the box is 0, 1, 1. The sum of the box is 2, which means if you play 3 times, you're expected to win $2. The average of the box is 2/3, which means every draw is worth 66 cents on average. So I times that by 100. So 0.666 times 100 is 66.66. So if you play 100 times, you're expected to win $66.66. Okay? Any questions about that? All right, number 6. A game is fair if the expected value for the net gain equals 0. What does that mean? How do you know if a game is fair? Say that again. Oh, so you're saying the positives and the negatives? So if I have a box and these tickets are positive and these tickets are negative, so Megan's saying if you add these up and there's just the sum is the opposite of this sum. Yes, that would work. So if the game is fair, what is the sum of the box? 0. If the game is fair, what is the average of the box? 0. How many games in Las Vegas are fair? I've seen one. And I wonder if there was a trick to it. I didn't study it enough to see, but I have seen one um, that anyway, I want to go back and look at it, see if that game still exists. Well, so it's illegal to find flaws in the randomness. So if, for instance, there was a statistician who thought that roulette wheels were not um, random. And the reason is the roulette wheel sits on a big bearing, and the roulette wheels are really heavy. And it's got a big bearing in there, and that bearing has imperfections in it. And that imperfection causes slight tilts. And because of that slight tilt, one side of the board, one side of the wheel, is more likely to show up than the other side. So this guy was crazy. Um, really smart, though. He and a bunch of college kids that were in his class, uh, he was a professor, went around and studied roulette wheels at all these different casinos. And they did so as a big group. So he might say, you two go here, and you two go here, and you two go here. And the next day, he would change their outfits and give them facial hair and hats. And then he would put, okay, you two were here yesterday, so one of you go to that casino, and one of you go to this casino. And they studied all these roulette wheels, and they realized that every roulette wheel had a tendency towards a specific set of numbers. It wasn't a lot, but there was a little bit. So once they had gathered all the data, then he gave them all a bunch of money and told them how to bet and dressed them up and sent them to new casinos. And the casinos didn't catch on because people were winning money, but it was different people. And even, they would make you look like one thing one day and then put a wig on you and some facial hair and totally different clothes the next day. And they won a lot of money from the casinos. Eventually, they got found out, and the money had already been given to them, so um, they were banned from the casino. Um, but then the casinos realized, oh, we know how to fix this. Every bearing for every roulette wheel could be interchanged with other roulette wheels. So the wheel itself is not perfectly made, and the bearing is not perfectly made. So every day, they would just pop the bearings out and switch them out with different wheels. And you had no idea where they would end up, and so you'd have to re-evaluate which numbers come up the most. And you couldn't really, you didn't know which bearing was on which wheel, and then they would move the wheels around, and it turned out that it totally ruined their chances of roulette. So now they just mix it up. But if you get caught doing that, then they will ban you from the casino, right? If you get caught with a specific edge, then they'll ban you from the casino. I don't think that the bet $1, bet $2, bet $4 is illegal. I'm not sure, but I don't know. I want to go find out. Anyway, back to this. No game in Las Vegas is fair, except maybe the weird one I found that involved dice. But maybe they don't let you play it the way that I would want to. So, number 6. On the average, players neither win nor lose. A generous casino would offer a bit more than $1 in winning if a player staked $1 on red and black in roulette and won. So in roulette, if we bet black, there are 18 plus ones, and then there are 20 minus ones, right? We could create a roulette wheel such that its sum is 0. Okay, what would I need to do to this in order for the sum to be 0? This would have to be a little bit bigger than plus 1. How much bigger? Well, I want 18 times something to equal 20 times 1, right? Because I want those to have the same weight. So we put x there. So x would be 20 divided by 18. So if you won $1.11, and I mean 11.11111111 cents, then roulette would now be a fair game. Yeah, so you could just build a wheel that didn't have any greens. That's another way to do it. But the wheels, I mean, assuming the wheels had already been cast, the way to make it even is to pay out 11.1 cents more than the $1 winning that you would give them. Okay. Oh, that's it. That's the question, huh? No, I did it. I thought I was leading up to a question. Okay, that one's done.